So hello, we're starting up part 2. This video is going to cover intercept form. We also call that factored form, and it's also going to cover standard form. So please follow along. Again, we're working with the next part of the worksheet, so you would probably want to jump back into the top of the worksheet where we have number 8, and in number 8 you can fill out some of the important information. You could do this in your notebook too if you want to just copy everything. That might be possible. Just maybe pause the video so that you can get all this information copied down if that's the case. But otherwise, the PDF is on Google Classroom, and so you can go ahead and take this. I might be able to attach it to the bottom of this video also, so maybe you could get that file from there. So in intercept form, we should be able to see it by looking at it. Intercept form has 2 parentheses, unlike vertex form where there was only 1 parenthesis. So we also call this form factored form, and we've used this before. And the big idea about factored form is that this is going to be something that doesn't give us the vertex just by looking at it. So I noticed right here when I made this, I'm going to go edit that right now, is that it says vertex form, and that's incorrect. So I better go in there and make sure that you guys do not treat that the same as vertex form, because it's different. And so that actually shows me that there's a, at least we get to have this valuable conversation right now about this, that this is not vertex form. This form is intercept form, and we also call it factored form. So now we could jump in and do this with everything labeled right, and when I attach this file, it'll be the correct file. Let me just save that. So now we'll take a look at the way that this works. The big idea of intercept form is that what it gives us is the x-intercepts. We should be able to tell what they are just by looking at it. So in vertex form, we had to change the sign of one number. Whereas in intercept form, we have to change the sign of both of these values, these numbers that are going to be inside of the parentheses with x. So when I see an intercept form equation and it says x minus or plus something and then x minus or plus something, this tells me that the x-intercepts have to be A and B. And we want to have special attention to the idea that these have opposite signs to the values that are inside of the parentheses. So we want to be used to changing the sign there. So we'll have to practice that. So we'll have to change the sign of both of them. Again, we cannot look at this and think that we have the vertex. To get the vertex, you'll have to do this calculation. This means that we'd have to add up the values of A and B and then divide by 2. Now, that's something you could do with numbers, but I would recommend that we take a look at the graph before everybody just starts trying to do this, because again, with negatives involved, you could easily mess this part up if you forget about a negative and don't add up the correct way. So this formula will work if you follow it, if you added up the 2 values that we had and then divide by 2. But you want to make sure that you're actually combining these numbers the right way. So, as it says up here, what is something important to keep in mind about the value of the x-intercepts and the numbers that appear in the factored form? We know that they have opposite sign. Okay, I don't want this video to run too long, and so I'm going to make this sentence short. But what do I mean by they? By they, I mean the value of the x-intercepts and the numbers that appear in factored form. Those have opposite sign. Okay? And how do we find the axis of symmetry? Well, the axis of symmetry is halfway in between the intercepts. So this is something that I think everybody that graphed these correctly on the last exam seemed to have known, and a lot of other people that got this problem wrong if they attempted it, what they did is they assumed that they could get the vertex just by changing the sign of these numbers maybe, okay? And you got to understand, that's not the vertex, those are the x-intercepts, okay? So halfway between the x-intercepts. Okay? So now, let's consider what all these things are. If I have my graph, and this is my parabola, you know, this point right here at the bottom of the parabola where it turns around, that turning point is called the vertex. Now, these 2 points where the graph crosses the x-axis, we call those the x-intercepts. Okay, it's a fancy word that means where does it cross the x-axis, okay? This graph crosses the x-axis at these 2 places, and so we call those the x-intercepts, okay? So there's one on this side, and there's another one right here. Those are both x-intercepts, okay? And like we said, when we want to find the axis of symmetry, we know that that is halfway in between the x-intercepts. Now, that's where this divided by 2 comes in hand, right? That's going to help us get halfway in between them. Notice that we know that the vertex and the axis of symmetry have this x value in common. Those are the same thing. But for us to find the y-coordinate of the vertex, we're going to have to perform this calculation, where we plug this number back into the function and figure out what it is. So that'll help us plot the vertex. So this process is going to be more involved, and before we can draw these graphs, we will need to find the vertex. So let's go do some of these examples, again in factored form, and let's try to make some of these automatic, again drawing these functions. I think the big idea that I wanted to have people understand here for the multiple choice values was we want to be able to look at this graph and then quickly say which equation we have to have. And so I taught people in factored form or intercept form, whatever you want to call it, either way it's the same form. We should be considering the idea that these intercepts is what we're looking for. Now we are not looking for the vertex. We don't want to just go there and be like a robot and just automatically do what we did last time. We have to read the question and think about what it means. And in this case, it says to find the intercept form equation. So if I was to write the vertex form in here, some people might choose it. And that would not be answering this question that wants us to find the intercept form equation. So what I'm telling everybody to do is go look for the intercepts, the x-intercepts. And we want to find that and find out where they cross the x-axis. Again, this graph crosses in these 2 places. We're going to change the sign of those numbers and look for the correct equation. So some people might accidentally choose A, which again, that would be intelligent because you see a -1, you see a -3, right? I see the -3 that's like there. I see the -1 that's right there. And I also notice that this is a sad face parabola. So this leading negative right there, it makes sense. And I know you're actually processing a lot of the information that we're getting here, but that would be incorrect because we have to change the sign of these numbers to correctly do this in intercept form. So this should not be the answer. The answer should be that I'm changing a -3 into a +3 and the -1 into a +1. And so the answer would be B. Okay, again, this has the leading negative, and that makes sure that we get this sad face over here on the side, this parabola that is open downwards. So let's try another example of multiple choice before we go get into the graphs. Okay, in this example, we want to do the same thing. We want to read the equation, we want to read the question, and make sure we're doing the right thing. This says to write the intercept form equation, not the vertex form. We're writing intercept form. And so what that means is that we find the intercepts. I see that this crosses here and here on the x-axis. Okay, so these x-intercepts are these points that we see right there. And that tells me that I'm going to have to change the sign to the opposite sign. So I'm looking for a -5 and a -7. And I see that that is right here. And so our answer would be D. I don't see any of these other possibilities. This is a +7 and a 2, so that's definitely not right. It does have this 7, but this isn't even a changed sign. And in this case, it doesn't even have a 5, so we know that we're in the right here to choose D. So now we'll take a look at the next one. And here we see that all of these other forms are in standard form, which we'll cover later on in this video. Standard form will be the next one we look at. But this idea is like pretty basically something that you could choose automatically because none of these are even in the correct form, okay? Not to mention that they all have a leading negative, and so that would give us what's called a sad face, and this is a happy face, right? You see, that's a happy face parabola. So I know that I should, by process of elimination, be able to cross out A, B, and C, because they all had a negative leading coefficient, and I know that I'm going to have to go with D. But again, to focus on the x-intercept, we know that that crosses at positive 3, so I'm going to change that into a negative 3, right? And then this as a negative 1, so I know that's going to give us the opposite, where I have to have positive 1. And again, this would be the x minus 3 instead of x plus 3. So make sure that you change the sign of both of these values. And let's see if we find that. And of course, we see that it's right here. We got x minus 3 and x plus 1. So this would be the correct equation. So if we take a look here, you might want to choose on your own and pause the video and decide which one you think the answer is. And I hope you actually paused it, and we'll go over the answer right now. Again, intercept form means that we want to find the intercepts. It crosses here at positive 6 and positive 2. And so I know I want to change the sign, right? This is going to contribute an x minus 6 to the equation. I have to change that 6 to a negative 6. And this positive 2 is going to change into a negative 2. Okay, in the next unit, we'll talk more about why this is true. But at this point, I don't want to lose anybody, and I want to make sure that we can just be fluent in reading all the parts of these equations. So the answer that we would pick would be D, and we would not want to pick C because these have the same signs. Okay, so that's just not the one that we would choose. Again, these other two options, A and B, are in standard form. They're not even in intercept form, so we know that couldn't possibly be the answer. So, like I said, in intercept form, we want to change the sign of both of the numbers that are inside the parentheses with x. We want to change the sign of both of those numbers that are the x-intercepts. And so let's be careful in this example, because I see that this crosses at negative 2. So I know that's going to give me a positive 2. We're going to change that to a positive 2. But this one, this is crossing at 0. So in this case, it wouldn't matter. You can't change the sign of 0 because it's neither positive or negative. So no matter what you do, you really can't get it wrong. If I write x minus 0 or x plus 0, it's the same thing. And so I would be looking for an equation that has x minus 0 times x plus 2, or the other way around, but we should realize that x minus 0 is just x. And so we can drop the parentheses, and we can basically end up with this form right here. And so we're looking at the answer in option C is the one that we should pick. Okay, we could also see that we knew we had to change this negative 2 into a positive 2. This one has a negative 2, and it even has a negative leading coefficient. So we know that this one would give us a sad face graph. So I know it can't be this one. Okay, this one would not be the answer either, because our graph doesn't have a y-intercept of negative 1. Since our graph isn't crossing at negative 1, I know I'm not changing to a positive 1, so this can't be the answer either. And then for D, we also wouldn't have that. So this brings us to another special case where we have only one x-intercept. It only happens once. And so in that case, we got to think a little bit and realize that intercept form helps us when the graph of the equation actually crosses the x-axis. Imagine that we had a parabola over here, right? So maybe graphs don't always cross the x-axis, right? They're always going to cross the y-axis because these graphs are infinite again, right? They'll go out forever. It's going to go out this way forever. It's going to go out that way forever. They'll eventually cross the y-axis, but because this graph starts right here and goes downward, it's never going to turn back around. It's never going to cross this line. So I know some graphs don't cross the y-axis, the x-axis, and therefore, since some graphs don't cross the x-axis, that means some graphs don't have x-intercepts. This graph has exactly one x-intercept, and in that case, we could think about this in vertex form and try to basically turn this into an intercept form and understand what happened here. If I was to write this in vertex form, just to try to find a way to express this, we would say, well, I know in vertex form I have to change the sign of that. So that would be x minus 5 and then squared. And then the number that I put here would be the y-coordinate of the vertex, right? But think about it. What's the y-coordinate of the vertex here? This is the point, right? There's a vertex, is the point. X equals 5 and y equals 0, right? Because y equals 1 is here, so y equals 0 is the x-axis itself. And so now, what's going to happen? Well, that tells me that I'm doing plus 0, because again, that's the y component that we have for this vertex. So if I do plus 0, that's just the same thing as nothing. I don't even have to write it. And so the definition of squaring something means to multiply it by itself. So by definition, x minus 5 squared means x minus 5 times x minus 5. So we see that now we've actually turned our vertex form up here. This was a vertex form. And we use that to write this in intercept form. Which would be like this, or like this. Either way, both of these would be intercept form. So I'm looking for option B. Or am I looking for option B? Because in this case, is this a happy face or a sad face? It's a sad face, right? So that means that I should have a leading negative. So we forgot to mention that. So let's go put that negative in there. And then realize everything else was right. But like I said, that should be one of the first things you see. Especially you can double check that process as we're checking the options, right? I noticed that this was an intercept form. And I know it wasn't this one because we had a positive 5 instead of a negative 5. But when I went to go look at the answers, I knew it was going to be one of these two. And then I realized, wait a minute, look at our graph. It's a sad face. This is positive, and this one's negative. So because this is open downward, right, we know that it can't be B, but the answer has to be A. So analyzing these multiple choice problems is going to be useful. I think if you can't do these ones, then you'll definitely be confused by actually drawing the graph. And so it looks like at this point we've actually finished those multiple choice questions. So let's go draw some factored form graphs now. So in the last video we did up to 33, so now we'll be jumping down to 34 so that we can do this graph. So again, if you have the worksheet, you could probably do this on your own. Pause the video and try to see if you get it right. But otherwise, if you know you're still stuck and you're not able to do this, let's do all the steps. We want to remember that we want to find the vertex and the axis of symmetry, okay? And we should, of course, be able to look at this and identify the form. That's one thing we're working on. And so we should see, okay, this is intercept form, this is factored form, whichever way we want to call it, they're the same form. So we should analyze this fact that we see we have a negative in front. So that tells us that we're going to get a sad face at the end, because we know we're going to have to also draw this graph. So 3 things we have to do, 3 points we want to consider. The vertex, I want to find that, but we don't know where it is yet. We also want to find the axis of symmetry, but we don't know where that is yet either. And the reason why we don't know that is because we do not have our vertex form. We have a different form, and so we want to make sure that we understand that by looking at this, we should be able to see the x-intercepts, not the vertex or axis of symmetry, not until we do some further analysis. So now let's change this positive 5 into a negative 5, and that's going to be this number right here. Then we're going to change this positive 1 into a negative 1, and we're going to plot those because, again, those are our x-intercepts. So we have those 2 points on the graph. And as we wrote earlier in our notes, the axis of symmetry must be halfway in between the x-intercepts. So I know that this line right here that I'm drawing, this dashed line, is our axis of symmetry, okay? An axis is another word for an imaginary line, right? Such as the Earth itself, right? The Earth spins around an axis, and it's an imaginary line. It's not really there except for, you know, in our imagination. So just realize that, you know, the axis isn't really part of the graph. It's just something that we use to help us analyze the graph. So now, we want to figure out where that is. Well, this is on the point x equals negative 3. So we know that this line is the line x equals negative 3. Like I said, every point on this line has a coordinate of x equals negative 3. So I know that the vertex has an x-coordinate of negative 3, because if you think about it, on any parabola, the axis of symmetry goes through the vertex. Okay? So, like we said, we do know the axis of symmetry, so now we're halfway there to getting the vertex. And once we get the vertex, and we have that number, we'll be able to draw this graph like all the other graphs that we drew last time. So let's go ahead and let's realize that we have to calculate f of negative 3. And what that means is that I'm going to put in all the parentheses and everything that I need. And like I said, everywhere where we see x, we put in a blank parentheses. Now, this might seem like an extra step, but eventually this will save us some trouble, okay? So everything else is copied, but where I see x, we have a blank parentheses. Okay, dealing with negative numbers can cause problems for some people because we can get a little superstitious and feel like the symbols are complicating things. But if we just break everything down, it's really not that bad. So just understand that we're having to count negative 3 plus 5, and that gives us positive 2. And again, negative 3 plus 1 gives us negative 1. Okay, so always just think of this as counting. Like I always say, think of it as you have $5 and you spend 3, then now you have 2. But if I only have $1 and I spend negative 3 out of my bank account is going to have a negative balance. So consider that, and now we realize that we have to do negative 2 times negative 1, and so a negative times a negative is a positive, and so we should have positive 2. And that tells me that that's the y-coordinate of the vertex. And so this was one thing that people had trouble with on our test, right? We knew that we had to put this together, and sorry, of course there was a mistake here. So let's run all this back. I said negative 3 plus 1 was 1, but actually it should have been 2. So I'll be sure to edit this part out. And mistakes are just part of math. So we'll just take that and just keep moving. So let's fix that again. Like I said, we have to plug in. We're going to copy everything else and realize the number that we're plugging in for is x. We're going to substitute, to be more technical, we're going to substitute negative 3 everywhere where we see x. So that means I have to do a calculation here and put in the result. So negative 3 plus 5 makes positive 2, and negative 3 plus 1 makes negative 2. And if I do negative 2 times negative 2, that makes positive 4. So now we know that this vertex is going to go in this location. So we're going to go to the left 3 and up 4, and then we're going to put our vertex right here on that spot. And now we can graph it in doing the same pattern as we did before, as long as we realize that because this is a sad face parabola, because this is open downward, again, because we have a leading coefficient that's negative, we're going to be going down. So if I go over 1, I go down 1. I go down 1 squared. If I go over 2, I go down 2 squared, and that's 1, 2, 1, 2, 3, 4. And we see that that point's already there. And so that's nice. We don't have to do those 2 points. And so likewise, what happens if I go over 3? If I go over 3 squares, and make sure we're counting the right way, if I go over 3 squares from the vertex, I have to go down 3 squared. And so that means 3 times 3. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I put this point down. Okay, same thing on the other side. If I go over 3, right, I go down 3 squared, which is equal to 9. And so I'm going to count down 9 squares and put that point there. And that helps me draw this graph a little quicker than I would otherwise. So once you see this pattern, you'll be able to work a little faster, and hopefully the next unit will make more sense as we continue to kind of study these functions. So notice all of our information is done. We have our vertex, we have our axis of symmetry, and we sketch the graph. And we know that when we're substituting in negative numbers, we have to have a little extra care to take a look at the graph and make sure that we understand that all these graphs should kind of look the same. As long as our leading coefficient is 1, we should be looking at the same pattern of over 1, up 1 squared, over 2, up 2 squared, over 3, up 3 squared, and so on and so on. Unless it's a negative, in which case we go downward. So let's go put these 2 points down, right? I'm going to change the sign of the -6 and the -4. So I'm going to go put a +6 and a +4 right there on the graph. And then what I have to consider is, where's the vertex? Where's the axis of symmetry? So for me to find those, I have to find what's halfway in between those 2 x-intercepts. And so what's halfway? I see this is the midpoint right here. Halfway in between 4 and 6 is 5. And so I know this is my axis of symmetry. This is the line x equals 5. Again, some people were doing good work, and they were putting these points over here, and they were saying, oh, okay, I see a -6 and a -4. Let me go put those here. We don't want to do that, because that's not what happens. That's not going to work for us here. So now, let's do the next step. We know that we have the x-coordinate of our vertex, but we don't have the y-coordinate. So let's go figure out how we have to do this. I'm going to calculate f of 5, and this is going to help us get the answer. Okay, but we have to make sure that we're copying everything, including that negative. So we have a negative here, and now I'm going to plug in 5. We're going to do 5 minus 6, and then times 5 minus 4. And take care with that negative. We copy that also. Okay, 5 minus 6 is -1. And then 5 minus 4 is 1. And now we see why these parentheses are there to kind of help guide us. Again, -1. What does that mean? Okay? Negative anything means change the sign. And to change the sign, we're basically going to think about what happens. So let's just copy this negative for now. And we could consider what's -1 times 1. And that makes -1. Okay, so when I see a negative outside of some parentheses, that means change the sign. So if I was to change the sign of -1, that means give me +1. So -1 is just +1. Okay, so math can be a little annoying and confusing sometimes when we're dealing with negatives, but that's part of why we're studying this, so that we can get some mastery here. So now I know where the vertex is. The vertex is at the point x equals 5, y equals 1. So that means if I go over 5, I'm going to go up 1, and that's the vertex right here. So this point is our vertex. Okay, this graph has a negative leading coefficient. So again, that tells me if I go over 1, I have to go down 1 squared. Again, if I go back to the vertex every time when I'm doing this. If I go over 1, I go down 1 squared. If I go over 2, I go down 2 squared, and 2 squared is 4, so that's 1, 2, 3, 4, and then I put that point down. Okay, if I go back to the vertex and I go over 2, then I got to go down 2 squared, so 1, 2, 3, 4, and put that point down. Okay, and like I said, all these other lines I'm drawing are just to make sure that you guys can follow how I'm counting and what I'm thinking about. So now if I go back to the vertex and I go over 3 squares, I'm going to go down 3 squared. So I count 1, 2, 3, and then I got to go down 3 squared, which is 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And put that point down. And that's on both sides. So there we go. We have everything that we need now. All we have to do is connect those with a smooth continuous curve, and that gives us what we need. So this graph would be done. And again, at the end, you should always go back and look at your equation and make sure that you did something that makes sense, because hopefully, if you know enough, you could say, okay, this is negative, leading coefficient, that negative tells me that this should be a sad face. It should be going down, it should be open downward, and so we know that we have everything again. We have the vertex and the axis of symmetry. We sketch the graph, so that gives us our full 3 points. So now let's continue and realize that this is pretty much the same idea, except in this case we don't have a leading negative. Right in front here, I don't see a negative anymore, and so this problem looks just like the last one, except for we'll be going up this time. So again, I'm going to change the sign of both of these numbers. We're going to change the sign of that and that. So we're going to have positive 6 and positive 4. Those 2 points are our intercepts. I know that my axis of symmetry is going to be halfway between them, and that's the line x equals 5. I know that I'm going to have to calculate f of 5 so that I can get where I put the vertex. So let's go do that calculation. So that means again I have x minus 6, and then I have x minus 4, and the number I'm plugging in for x is 5. So I have to do 5 minus 6 times 5 minus 4. 5 minus 6 is negative 1, and 5 minus 4 is positive 1, and so this gives me negative 1. And that tells me that what we should have is our vertex at the point (5) and negative 1. So now we follow our quadratic growth. Of course, we know the axis of symmetry, we just labeled it. We know our axis of symmetry is x equals 5. So now all we have to do is our quadratic growth pattern, right? We do this idea that if I go over 1, I go up 1 squared. If I go over 2, I go up 2 squared, and 2 squared means 4. So that's 1, 2, 3, 4, and I put a point there, right? If I go over 2 from the vertex again, I got to go up 4 squared, and so that means I put a point right there. And if I go over 3 from the vertex, I have to go up 3 squared, which means 9. So that means I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and put a point down. And again, that's going to be on both sides. So we can see that this axis of symmetry helps us graph a little faster. And we connect all of our dots and include those arrows to show that it continues to go on forever. here we have it. Let's continue working. We had all our information included. So now we could do this version of the problem. Might be a good time for you to pause and try it on your own and see if this process is making sense for you. And hopefully it makes sense and your graph is going to look like the way we draw it right now. So again, we know we need that vertex, but we don't have it until we do a little bit of thinking. So I know I have to change the sign of these two values to get my -6 and -4 x-intercepts. Then I want to realize what's halfway between them. And in this case, I see that that's the line x equals -5. So that's our axis of symmetry. And it's also going to basically be the x-coordinate of our vertex, because we know the vertex has to be on the axis of symmetry. So that means that I have to calculate f of, sorry, not +5, but -5. I wrote it correctly over there. So we have -5 here. So let's calculate f of -5. And what that means is to plug in -5 everywhere we see x, and we copy everything else. So -5 plus 4, -5 plus 6 makes 1, -5 plus 4 makes -1, and when I multiply those out, I get -1. And so we just found the y-coordinate of the vertex. And so that tells me where to go put the vertex, and that means I can place it right here at -5, -1. So now we just use our quadratic growth. If I go over 1 again, I go up 1 squared. If I go over 2, I go up 2 squared, which means 4. So that's 1, 2, 3, 4. And I put a point down there. If I go over 3, I got to go up 3 squared. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I put a point down right there. And if we can practice reflecting our points across, we can see that this distance is 2, and then there's another 2. So I know those are reflected. The same way, this is 3 steps over here, so I know my other point should be over here 3 steps. And we could do the rest of those and just connect them with a smooth continuous curve. And then again, remember that we have everything we wanted: our vertex, our axis of symmetry. We sketched the graph. We realized, okay, this is a positive leading coefficient. That's an invisible one, so we were right to have one of these happy faces. So we're doing this the right way. So now we can move on to another example. And there we go. We see that we actually completed the set that I had intended for factored form. So now we can go look at standard form, and I'll keep that in this part of the video. So that I don't have to make another video. I guess, what do you think? Maybe I should separate these two? So I'll go ahead and separate them, right? You guys don't want to see a longer video, so I'll make this part 2 will be on factored form and intercept form. So look out for part 3 is coming up next on the channel, and you'll be able to see how to do standard form. So we'll take a look at this in the next video. We'll call that part 3 on graphing.